So here are 3 simple problems on right-hand rule. The right-hand rule, second version, trying to find force. Force on a charge or force on a current, the magnetic field. And let's just review this briefly first. So what we have is you take your right hand, you have these fingers here, and here's your thumb. You always align your hand in such a way that the magnetic field points along these fingers, direction in which the charge moves, or the direction of the current points to the right, the conventional positive charge. And then the force comes out of the palm of your hand in such a way that it is perpendicular to the palm of your hand. So this is the right hand rule. And you should have watched the video explaining that right hand rule and doing some examples, but now we will solve a couple problems. Here's one problem. I'm going to draw 4 different magnetic fields. So here's the first magnetic field, points into the page. I'm going to call this B, and I'm going to put in, just to make sure, into the page that you know that this magnetic field points into the page. Here's another magnetic field. This magnetic field here points to the right. Here's another magnetic field. This one points down. So we have the magnetic field here, B, that points down, and the fourth one is going to come out of the page. So I'm going to put a bunch of dots indicating that this magnetic field here comes out of the page. So this is B out of the page. All right, now let's call this problem number 1. And this is in a this is taken from a textbook, but not your textbook. So just going to call this number 1, and let's say that you place a charge Q here, and you let this charge Q move with speed V, with velocity V upwards. Here's velocity V. Here's a charge, this field, charge Q. Label this as Q as well. And this one is moving up also with velocity V. Determine the direction of the force acting on these using the right hand. I'm going to put a charge here as well, label it Q. I'm going to put a charge here also, label it as Q. All of these charges are positive charges. Here the charge moves with the velocity in this direction, and here the charge moves with the velocity in this direction. Right, so now you can pause the video and see if you could figure out the direction of the force. I'm going to do this in a second. Let me do this one first. I would have to take my hand and align it like this. My fingers point in the direction of the magnetic field. And, well, looking at it, here I would have to have my thumb actually point up. There's my thumb. And since this must be a right hand, the only way this would work is if the force, magnetic force on this particle points into the page. Take your right hand and align it with this little picture, your right hand. The only way this would work is if the force comes out of your palm and points into the page. So I'm going to put this force points into the page. Let's do this one. So the fingers now point down. 1, 2, 3, 4, and the charge is moving to the right. So here's the thumb. Again, this is the right hand. So the only way this would work is if the force acting on this particle comes. Oh, look at that. I was well, anyways, let's do this one and then we'll correct the other one. So here the force points comes out of the page. This is F. that one over there, this is actually pointing into the page. So if we go back to this force here, it should be pointing into the page. It should be X here, right? If this is your right hand, then and the force has to come out of the palm of your hand, then it has to point into the page. And here in this case, the force must come out of your palm, and if you're using your right hand, this must be coming out of the page. Right, now we can do the other. So it's difficult to draw this. I'm just going to go over the answer. I'll state the answer. So in this case, I would have the hands, the fingers of my right hand point. They would be pointing out of the page, and then rotate my hand so that velocity points this direction. Therefore, the force is up. So here the force is up. It's F. And then here in this case, you have the magnetic field that points into the page. So I put the fingers of my right hand pointing into the page, and then my thumb points up. Therefore, the force is to the left. So the force here would be to the left. It's force F. Okay, now we'll solve the same problem, but instead of having an individual charge, we will have a current that flows through the same magnetic fields. So let me redraw this. All right, so now we have these magnetic fields. These are the same ones as in the first problem. And now what we'll do is we're going to place a wire here that runs up like this. And there's a current I that points here. In this case, we will also put a wire here where we have the current I that flows upwards. This is a conventional current. And then here in this case, we're going to have current I that flows in this direction. And this is again the conventional current. And then we will have a current that flows through this magnetic field to the left. And this again is a conventional current. The rule is the same for these, and that is you take the right hand. These are your fingers. This is the thumb. The magnetic field, you align this hand such that these fingers here point in the direction of the magnetic field. This thumb here points in the direction of the current in this specific case. And then the direction of the force is determined by the palm of your hand. That is, the force is perpendicular to the palm of your hand and comes out of your palm like this. To that perpendicular to the surface, and this is force F. All right, so this is virtually the same problem as the one you just did. That is, in this specific case, let's do this one first. You would have the magnetic field that points to the right. Here are 4 fingers, and then I points up, so my thumb has to be here. This is the right hand. Therefore, the only way this would work is if the force points into the page. This is the force acting on this wire. It just points into the page, so the wire will be pushed into the page. In this case here, the magnetic field points down. So we have the fingers here like this, 2, 3, 4. The thumb points to the right. And remember, this is the right hand, and so the only way this thing would work is if the force on the wire was coming out of the page. And so I'm going to put a bunch of dots here to indicate the direction of the magnetic force. Right, and then let's do this one. So here, magnetic field points into the page, current flows to the right, therefore the force is downward. So the force acting on this wire everywhere here would just point down. This would be the force F. And then up here, if the magnetic field, oh, actually, go back. This is if the magnetic field comes out of the page, current flows to the left, and the force actually points up in this case. So the force here should be pointing up. And then for the first one here that we had, the magnetic field points into the page, the current flows up, therefore the force is to the left. The force acting on this wire would point to the left. This is force F. And again, if you're not sure why is it that this is how you would determine the direction of the force, you should watch the video on the right hand rule. Spend half hour over there showing different examples and how this works. Now, the third problem I will look at here is what would happen if you now replaced this current with a negative charge. And so let's do the third problem here. All right, so the third problem would be the same as this, but now instead of a positive charge, we would put a negative charge all over the place here. So let's Well, let's cross this out and call this problem number 3. Now, when it comes to determining the direction that the force would act on a negative charge, let's do it like this. Here's the negative charge. It moves in the same direction. It moves up. Because it's a negative charge, the force on this thing would just point in opposite direction. Let's move on to the next example. Here is a positive charge. Now consider a negative charge. And let's let this negative charge move up with velocity v. In that case, the force acting on this charge would be opposite from the positive one. So this would be pointing out of, the force here would be pointing out of the page. Move on to the next one. If I put a negative charge here, and I let this negative charge move with a velocity v to the right, I'm sorry, to the left, then the force acting on this charge will point in the opposite direction. We'll have the same magnitude, but it will point in the opposite direction of the force above, and therefore this would be into the page. And then the last one here, if I take a negative, make this, let's add the magnetic field. Let's expand this magnetic field a little. So let's say I take a negative charge now and I place it here. And I let this charge move in the same direction as the positive one above, velocity v. Then the force acting on this charge would be the same as the one above, but it would point in the opposite direction, and so therefore it would be down. All right, so would be the 3 sample problems determining the right-hand rule. 3 simple problems for determining the direction of the force on a charge magnetic field using right-hand rule.